Imagine for a moment just the sheer volume of video content that's out there. You've got security footage from last night, maybe decades of old broadcast archives, even your team's online presentations from like last week. For way too long, this has just been this dark, passive ocean of data. How many, game-changing insights, how many critical warnings, how many just surprising discoveries are locked away, unseen, unheard, just waiting for someone to maybe manually review them.
It really is a gold mine of information, isn't it? Just sitting there waiting to be tapped and turned into something genuinely useful.
Exactly. And that's pretty much what this deep dive is all about today. We're going to try and unlock that potential by digging into Microsoft Azure's really powerful video analysis services.
Yeah.
Our mission here is to show you how Azure takes that raw video footage and transforms it into actionable intelligence, digging out those meaningful insights you maybe didn't even know were hiding there. We're going to look at two core services, see what makes them unique, and then jump into some really fascinating real-world examples where they're already making a huge difference.
Yeah, think of it as moving beyond just watching video to actually understanding and acting on what's inside it, whether that's in real time or digging through huge archives. We'll focus on the two main ways Azure approaches this. There's Azure AI Video Indexer, the one's great for understanding what's in the video content itself. And then there's Azure AI Vision Spatial Analysis, which is more about tracking movement and interaction within video feeds. And these aren't just like technical tools buried in menus. They're really solutions to very real business and operational challenges.
Okay, so unlocking insights. But Azure isn't offering just one magic key here. They've actually got two different services for video analysis. So that makes you wonder, why two? And how do you figure out which one is right for what you need?
That's a really crucial distinction. It boils down to the fundamental types of insights you're trying to get and, well, where your video is coming from. So on one hand, you've got Azure AI Video Indexer. Now, this is a pretty robust cloud-based service. It's specifically built for deep automated analysis of stored video files. Its main job is comprehensive content understanding. So think media analysis, detailed transcription, deep indexing of stuff that's already recorded. Could be an old TV show, could be a corporate training video.
Right, so Video Indexer sounds like the ultimate librarian for your video archive, basically making everything searchable.
Got it. Now, how does the other one, Azure AI Vision Spatial Analysis, how does that compare? Spatial analysis comes into play when you need that real-time awareness. It's designed specifically for live video streams, and importantly, it's deployed on the edge. What that means is the processing happens much closer to where the video is actually being captured, like right there on your factory floor or in your retail store.
Yeah.
Primary focus, movement tracking. So imagine counting people as they walk into a specific zone or monitoring the flow of traffic somewhere busy, all happening, pretty much instantly.
Okay, so it really comes down to whether you're analyzing a library of videos you already have or if you're tracking live activity as it's actually unfolding. And like you said, it's not about one being better, really, but picking the right tool for that specific job. This gets super clear when you look at the core differences, right? Video Indexer, that's all about cloud-based analysis, making those stored files for content understanding, and you deploy it just as a cloud service. You upload, it processes. Simple enough.
Exactly. And spatial analysis. That's engineered for the edge, for real-time processing, working with live streams. Its core strength is that movement tracking, and it gets deployed as a container on powerful edge devices. So that makes it perfect for things like real-time people counting or dynamic zone monitoring. They actually complement each other really well, tackling different sides of video intelligence.
Okay, let's really dig into Azure AI Video Indexer first. You mentioned it runs over 30 AI models. What does that level of analysis actually unlock when it looks at a video?
Right, so when you send a video to Video Indexer, it's not just doing a quick scan. It uses over 30 sophisticated AI models, all working together on both the video and the audio. This means it doesn't just hear what's said or see what's visible. It's understanding context, emotion, identifying specific things. And the output is this rich JSON file. A standard data format, easy to work with, that's just packed with detailed insights. Things like transcripts, text it reads off the screen using OCR, faces it detected, topics it identified, even emotions. So it's way beyond just transcription. It's about unlocking the video's hidden story and making it as searchable as, say, a text document. That's a total game changer for anyone with large video archives.
30+ AI models. Wow, that's impressive. Let's start with the audio side. What exactly can it hear and understand in there?
Well, for audio analysis, it's incredibly powerful. It's great at speech recognition and transcription, turning spoken words into text in, I think, over 50 languages now.
Yeah.
It automatically figures out the main language being spoken. It can handle multiple languages mixed together in the same audio smoothly. And here's a kicker. It can identify and map up to 16 different speakers in one audio file.
16 speakers.
hmm
Seriously?
Yeah, so it's basically doing the work of a ridiculously patient meeting transcriber, times 16. No more guessing who said what
Mm.
in those long recordings.
Okay, that is a huge time saver. And beyond just the words, can it pick up on other audio cues, like background noise or...
Oh yeah, it includes advanced audio processing, like noise reduction. It's actually based on filters used in Skype, which helps clean up, say, phone call audio or just noisy recordings in general. It can do two-channel processing to automatically detect separate audio tracks and merge them into one single timeline. And yes, it detects specific audio effects. Think clapping, laughter, even things like sirens or glass breaking. Plus, it can take those audio transcripts and translate them into many different languages, which is great for breaking down communication barriers.
That's a lot of listening. What about the visual side? What does it see? How does it analyze the visual stuff?
Visually, it offers really solid face and people detection.
Yeah.
And it's not just detecting that a face is there. It can recognize and track specific individuals across the video content. It can even pick out specific clothing items they might be wearing. It effectively tracks people's paths, with bounding boxes showing where they are as they move through the video. So you get movement data alongside the content insights.
And what about objects and scenes? Can it understand the environment itself, what's going on around the people?
Absolutely. It automatically identifies and labels common objects like a cat, a table, a car, a ball, whenever they pop up in the frame. It can break down longer videos into different scenes or topics, which really helps you navigate. And its optical character recognition, the OCR, is fantastic. It extracts and groups text that appears, maybe as overlays or on presentation slides or even just signs in the background, making all that visual text searchable too.
Okay, so it's not just seeing and hearing isolated things. It sounds like it's truly understanding the context and the meaning within the content itself.
Exactly. That's where the content intelligence part really shines. It does topic inference, so it extracts topics based on keywords using established systems. It knows industry standards like IPTC that's common in news and media classification. It even uses its own kind of topic map to link related concepts. So keywords like stock exchange or Wall Street might roll up to the bigger topic of economics, giving you that deeper layer of understanding. It also performs sentiment analysis, figuring out the emotional tone, and named entity recognition, which pulls out brands, locations, specific people mentioned in speech or seen in text using natural language processing.
That sounds incredibly rich. For the developers or users listening, how do they actually get their hands on all these insights? How do they interact with it?
So developers can easily work with it using APIs, application programming interfaces, basically the standard way software talks to software. You use these APIs to get access tokens, upload your videos, tell it to index them, and then pull down that rich JSON data with all the insights. And to make things even easier, especially for putting it into your own apps, you can embed pre-built widgets. There's like a player widget for the video itself and an insights widget that displays all the extracted metadata right there. Makes integration pretty seamless.
And you mentioned something really cutting edge earlier. It's integration with large language models. Can you unpack that a bit? What does prompt-ready video insights mean for, for someone listening? How does that change things?
Yeah, this is fascinating stuff. Video Indexer can create what they call prompt-ready insights for LLMs. What this means is the metadata, it extracts the transcripts, keywords, summaries, all that it's formatted perfectly so you can feed it directly into a large language model like GPT or similar. So instead of you manually digging through hours of video, you can just ask questions about your video content in plain English, or ask it to generate a quick summary, or search for specific moments using natural language. It basically makes your video library as searchable and queryable as, say, a folder full of text documents. It fundamentally changes how you can get value out of your media.
Wow, that is a huge leap forward. Okay, let's shift gears now to the other service, Azure AI Vision Spatial Analysis. So far, we've mostly talked about understanding content that's already been captured and stored. But what if you need to understand events as they happen, live, in real time? That's where spatial analysis comes in, right? Enabling action, not just insight.
That's absolutely right. This service is purpose-built for detecting and tracking human movements, but specifically in live video feeds. What it outputs is specific event data. Things like the precise coordinates of where a person is what we call bounding box coordinates. or event types, like maybe someone entering or exiting a specific zone or crossing a virtual line you've drawn. It even assigns these pseudonymous identifiers to track individuals anonymously, which is obviously key for privacy.
Okay, so what are some of the practical, like, day-to-day operations it performs? What can you actually do with it?
Well, its core operations include really accurate people counting. So counting how many people are in a specific zone over a period of time. This is super valuable for estimating occupancy in, say, a retail store, or maybe triggering an alert if an area gets too crowded. It also offers zone monitoring. This tracks how long people stay in a certain area, or maybe when they enter through a particular doorway. Gives you crucial data on customer flow and engagement patterns.
Can it detect more subtle things than just whether someone's there or crossed a line?
Oh yeah, it goes much deeper. The spatial analysis operations can be configured to detect the orientation a person is facing, like are they looking towards a display? It can detect their speed. And get this, it can even detect whether they are wearing a face mask. It also provides dwell time analysis, calculating precisely how long someone spends in a specific zone. Imagine instantly knowing that the shoe section is a dwell time hotspot every Tuesday afternoon, while maybe the hat section is getting ignored. No more guesswork for store managers.
That face mask detection is very relevant. And how is this real-time magic actually achieved? You mentioned it runs on the edge. What's the deployment setup look like that allows for that immediate processing?
Right, that edge deployment is key. These complex AI models run on powerful edge devices, specifically ones equipped with NVIDIA T4 or A2 Tensor Core GPUs. These are specialized graphics cards really designed for heavy AI workloads. The power of these GPUs lets them process video frames incredibly fast, capable of handling, say, up to 20 concurrent video streams on just one GPU. Recommended hardware includes things like Azure Stack Edge Pro, which has that NVIDIA T4, or Azure Stack HCI devices that also use NVIDIA GPUs.
So it's not sending all that raw video up to the cloud, which would cause huge delays and use tons of bandwidth. It's doing the heavy lifting right there. How does it then communicate the results, the insights?
Exactly. The raw, high-bandwidth video processing happens locally, right where the action is. Spatial analysis integrates really nicely with Azure IoT Edge for deploying containers, basically, packaging the AI models and everything they need into self-contained units that run on your Edge device. It then sends only the event data like person entered zone X at this timestamp, not the raw video, up to Azure IoT Hub. IoT Hub acts like a central message hub for handling all these real-time events and triggering alerts. You could imagine, for example, a real-time dashboard powered by something like Signal-R, ensuring immediate updates to screens, showing updated counts, maybe flashing warnings if a zone goes over capacity. It's all about timely, actionable intelligence.
Okay, so bringing this all together, what does this actually mean for you, the listener? Where are these powerful technologies really making a difference right now? What kinds of problems are they solving? Let's maybe start with media and entertainment.
Yeah, in media, these services are revolutionizing content discovery and search. You can automatically create things like trailers, highlight reels, content for social media, or news clips just by extracting keyframes, scene markers, timestamps. For example, it allows for automated tagging and categorization of news content. It can even suggest headlines based on the topics and entities it identifies. Think about the hours and hours saved for production teams.
Oh, I bet. That would be a massive time saver. What about retail? How's it impacting shops and customer analysis?
For retail and customer analytics, these tools fundamentally optimize store operations. By analyzing customer flow with spatial analysis, businesses can pinpoint peak hours, map out the popular zones, understand dwell times accurately, and that in turn helps generate data-driven recommendations for staffing levels, or maybe helps optimize the store layout for better sales and a smoother customer experience.
And in really critical areas like healthcare and safety, how are these tools being applied there?
Healthcare sees significant benefits, particularly in enhanced patient monitoring and safety. This could include real-time hospital occupancy monitoring, generating alerts when capacity limits are reached. And crucially, it can help monitor PPE compliance using features like that face mask detection we mentioned to help ensure safety protocols are being followed, especially in sensitive areas.
Manufacturing and industrial safety must be another huge application area too, I imagine.
Absolutely. Spatial analysis is great for monitoring workplace safety. It can use its person attribute classifier to determine if people are wearing the correct uniforms or required personal protective equipment, things like hard hats, safety vests. This can generate detailed safety compliance reports for specific zones, identifying potential issues almost instantly, which greatly enhances worker safety.
I can really see this being incredibly useful in education and training as well. Just think of all those recorded lectures universities have.
Indeed. Educational institutions can analyze lecture videos to make searching for specific topics much, much easier. It helps students study way more efficiently when they have accurate transcripts. It can even automatically create study guides, identify key concepts discussed, maybe even generate review questions based on what was covered in the lecture. Imagine quickly finding the exact moment the professor explained that really complex theorem.
Definitely. And of course, security and surveillance. This seems like a very natural fit for real-time monitoring capabilities.
It really is. These services enable much more advanced threat detection. They can help identify things like tailgating someone following too closely through a secure door, or people maybe lingering too long in restricted areas, or even intrusion into secure spaces. You can build these comprehensive security monitoring systems that actually assess threat levels, create actionable alerts, and even recommend immediate responses like contacting law enforcement if a high-threat situation is confirmed, all based on that real-time video analysis.
Interesting. And beyond these external applications, can these tools help monitor themselves, in ensuring the systems running all this intelligence are actually healthy and performing well?
Yes, absolutely. You can leverage these same kinds of capabilities for performance monitoring and optimization of the video analytics systems themselves. This includes constantly checking service health, the status of those containers running on the edge, GPU and memory usage on your devices, and even generating recommendations for optimization to make sure everything keeps running smoothly without interruption. It's like intelligence monitoring intelligence.
Okay, this all sounds incredibly powerful, but how do we make sure it works effectively and, just as importantly, responsibly? What are some of the key best practices our listeners should keep in mind if they're thinking about using this?
Good question. For video indexer optimization, getting the content preparation right is absolutely critical. You really need clear, high-quality audio, ideally 44.1 kilohertz minimum, with as little background noise as possible, because, if the audio is garbage in, the transcription quality will suffer. For the video part, aim for at least 720p resolution, a stable frame rate, maybe 15 FPS minimum, good lighting, especially for faces, and use supported file formats. MP4 with H.264 codec is usually recommended. Also, keep files under, say, 2 GB and maybe 4 hours long for the best processing experience.
And what about when things go wrong, like with API calls? As developers know, network hiccups and things just happen sometimes.
Yeah, robust error handling is just essential for any system you put into production. You absolutely must implement retry logic, usually with exponential backoff, for your API calls. That just means if a call fails, you wait a little bit longer before trying again so you don't hammer the service. You also need code to handle common errors gracefully. Things like rate limiting, which is when you've made too many requests too fast, or unauthorized access, forbidden operations, resource not found errors, and just general server errors. Building this in makes your application much more resilient. Gotcha. And for spatial analysis, since that's often deployed out on the edge, what are the best practices for setting up that hardware and software environment? All right, for container optimization on the edge, definitely stick to the recommended hardware. Those NVIDIA GPUs, like the T4 or A2, are pretty crucial because they're specifically built for these kinds of AI tasks. You'll also want a decent amount of RAM, maybe 16 to 32 gigs, and SSD storage is better for faster data access. For configuring the containers themselves, a good starting point is maybe 8 GB of memory and 4 CPU cores per container. And remember, one GPU can typically handle up to about 20 video streams efficiently. Getting that balance right is key for performance.
And what about keeping an eye on it once it's deployed? Continuous monitoring.
Absolutely crucial. Use RTSP for connecting to your cameras. That's a standard protocol designed for low latency streaming, which minimizes delay in your live feeds. And definitely set up comprehensive monitoring using Azure Monitor. Track GPU usage, CPU, memory usage, and set alerts for them. This lets you proactively catch performance issues before they actually impact your operations. You want to know if a GPU is running too hot or a container is eating too much memory before it causes a real problem?
Okay, makes sense. Now, if we connect this back to the bigger picture, working with video, especially when it involves people, it naturally raises some important questions around privacy and how data is handled. How does Azure help organizations navigate those ethical considerations and compliance requirements?
Yeah, data privacy and protection are absolutely non-negotiable. Organizations have to ensure they're compliant with various regulations, GDPR, things like that. Azure provides specific features built in to help manage this responsibly. For instance, you can configure the services to require explicit opt-in for potentially sensitive features, like detailed face detection or maybe requiring consent before recording voice. Azure also supports automatic data deletion policies. I think there's a maximum retention of 30 days for the video insights data. and it provides tools for anonymization of faces and pseudonymization of speakers and transcripts. This really helps in generating those privacy compliance reports and ensuring you're using these powerful technologies ethically and responsibly.
We've covered a lot of ground today, from the idea of transforming that previously passive video into active, actionable intelligence, all the way to diving deep into the distinct powers of Azure AI Video Indexer and Azure AI Vision Spatial Analysis. It really feels like we're moving into a world where video is no longer just something you passively watch, but something you can truly understand and interact with.
Absolutely. You've got Azure AI Video Indexer, which just excels at that deep, comprehensive content analysis. Remember the 30-plus AI models, multi-language support, even those LLM-ready insights making archives searchable. And then Azure AI Vision Spatial Analysis providing that powerful real-time movement tracking, running it efficiently on the edge with privacy-preserving features built in, and really enterprise-grade deployment options for those live scenarios.
And just to recap for success, remember those key factors we discussed. Choosing the right service for your specific need is number one. Optimizing your input quality, garbage in, garbage out, right. Planning for scale so you can handle future growth. Always maintaining privacy and compliance. And continuously monitoring performance to keep everything running smoothly.
So here's a final thought to leave you with. Imagine a world where every video could instantly answer your questions, identify patterns you didn't see, or alert you to critical safety issues in real time. What new possibilities would that unlock for you and the work that you do?